Hi again, everybody. It was brought to my attention that there are some problems on the integration by substitution page that I do not have an example for, and they are quite a bit more complicated than the ones that we looked at. So I want to go ahead and put in an addendum video here, basically showing you how to do those specific problems. So I'm going to title this part of the notes U-substitution Part 2. to show you how to do these specific types of things. First of all, let's take this example of the integral of x squared times x plus 7 to the 4th power dx. So we're going to look at this specific problem. We have a lot of different things in here. The one thing I mentioned before was the fact that u needs to be the inner function. And I know there's multiple x's here, but the one that's really inside of something else is the x plus 7. So in this case, u is x plus 7, which means that du would just be 1 dx. Now, I mentioned earlier that you can never insert an x as part of your du, but sometimes you will come across a scenario where you have more x's than you need, and that's what's happening here. So let's take a look at what we have. We have an integral. I don't need to include anything. 1 is 1, so I don't need to do anything. So this here is du. This is u to the 4th, and now I have this extra x squared that I need to do something with. I can't just leave it in my integral because the integral, the new one, must be completely in terms of u. So what I have to do is I have to come back over here and I need to change this to something in terms of x. I need to write this as x in terms of u, actually, is what I meant to say. So take this problem here and solve for x. And in order to get x by itself, x would be u minus 7. Do you see what I did there? Move the 7 to the other side with the u. So what you're going to do now is you are going to replace the x squared here with what it equals in terms of u. So this becomes u minus 7 squared. So this is just a little bit weird as far as that's concerned. So now what we have to do is we don't want to do anything else after that. We should be able to turn this into something we can actually integrate. So multiplying these together, I would have to distribute out the u minus 7 first in order to do that. So this would be u squared minus 14u plus 49 times u to the 4th du. Because the power is 2, I can go ahead and just multiply it out pretty quickly. So this would now be, distributing the u to the 4th backwards, would be u to the 6th minus 14u to the 5th plus 49u to the 4th du. And now every term is a power function, and I can go ahead and integrate it as it is. So that would now be u to the power of 7 with a 1 over 7 in front minus, copy the 14, put your empty brackets, then put your u. 5's power becomes a 6. 1 over 6 goes in the bracket, plus, write the 49, draw your bracket, write your u. U's power here becomes a 5. In the bracket goes 1 over 5. And what do we always have to put on the end? Plus c. So now we're ready to change back to x's. So this would be 1 over 7 times u, which is x plus 7 to the 7th, minus 14/6, which you can reduce if you want to, but you don't have to, x plus 7 to the 6th, plus 49/5, x plus 7 to the 5th, plus c, and that is your final answer. I hope this helps with those problems at the end. In the section in the Griffith book from 17 to 28, this is where you're going to see those problems. So the u choosing between the x's, the u is going to be the inner function. Please omit 26, 27, and 28 because that is doing the logarithmic functions, which we have not learned yet. So please, if you're doing this assignment, do not go any farther than 25. And we will revisit this once we get to those log problems in the next video. All right, I hope this helps.